I'd like to pick up where we left off last class, back with that diver. And I'm still wondering exactly where he's located in relation to sea level. So during our Zoom lesson today, we'll find out. Here's one more problem for you to take a look at, because I find word problems can be a challenge sometimes, but we're going to do some easy ones to start off with. So see if you can find out just how many tennis balls are in 10 cases. And use some mental math. Now we've been looking at things that are equivalent. We just found a whole series of expressions that represent 12 in our last session. Reasoning and properties, they're used to show that two expressions are equivalent. We call this deductive reasoning. So it's a process where you're reasoning logically from given facts and you're drawing conclusions. To show that a statement is not true, we're going to find something called a counterexample. So if you can think of just one example that's not true about that statement, then we're going to deem it to be false. So let's take a look at some examples. The question is true or false. Is this a true statement? Is A times B equal to B plus A? I'll give you an example that supports that. I'm going to say, what if A were equal to 2 and B were equal to 2? I would have 2 times 2 and 2 plus 2. And I would get 4 is equal to 4, so I would say that's a true statement. Can you think of a counterexample? Challenges. Let's see what we came up with. If you've got that one, let's look at the next. For all real numbers A, B, and C, A plus B plus C, is that equal to B plus A plus C? Test out some numbers. You might think it to be true, test out a few more, and see if you find one that counters it. If not, then the statement is false. Another example, again, just to test out this deductive reasoning, for all real numbers m and n, is it true that m minus n is equal to n minus m? And we'll look at least one or two more, because this is, sort of a interesting way to explore numbers and their connections and seeing if we can think of things that are equivalent and draw conclusions. So take a look at the next one, and we'll look at some more examples in class. Our next section is going to focus on operations with real numbers. I'm sure you're all familiar with them, and again, being an introductory chapter, these lessons all are to refresh your memory. When adding numbers with the same sign, we simply add the numbers and keep the sign. When we're adding numbers with different or unlike signs, we need to subtract their absolute values, and the sum will keep the sign of the add-in with the greater absolute value. We'll go into some examples once again in class. I'm just looking at the rules quickly in this lesson, and this way you have them in case you'd like to copy them in your notes. We'll also talk about the inverse property of addition that says any number plus its additive inverse will give us 0. An example might be 7 plus its opposite, -7, additive inverse, will take me to 0. We can even prove this on a number line by showing that if we start at a number and count back, we're going to end up at the origin. I'm going to stop right there because I know we do have a quiz today, and we'll go over some of these other problems in class. So until then, good luck on the quiz, and I'll see you in our live session.